Welcome once again to the class. Let's move on towards our next problem. So, up to here we had already learnt, right, that you had found out the value of distance in terms of time, means distance is a function of time. Now, let's see. Find the law according to which the mass of the rocket varies with time. Okay, so you have to find out mass in terms of time now. When the rocket moves with a constant acceleration a, the acceleration of the rocket is constant, external forces are absent. This is very important point. Okay, F external is equal to 0 over here. The gas escapes with a constant velocity u relative to the rocket. The gas is escaping with a constant velocity u relative to the rocket, and its mass at the initial moment. What is its mass? Its mass at the initial moment equals m naught. Okay, now what does this mean? Means the initial mass before takeoff, just before takeoff, the mass of the rocket is m naught, and exhaust gases are escaping with a constant velocity u relative to the rocket. That is, your u relative is equal to u given over here, as given over here, and rocket moves with a constant acceleration a. External forces are also absent, that is, there is no gravity and there is no air resistance. Okay, so mass of the rocket, how it varies with time. When the rocket moves with a constant acceleration a, those things you have to tell you, that you have to find out mass in terms of t, that is mass as a function of temperature, mass as a function of time. Now, according to the question, what is given to you? According to the question, F external is equal to 0, already given. So from rocket equation, what do you have? You have something of this kind in the rocket equation, right? M dv by dt equal to F external plus u relative dm by dt. Now, u relative, what it comes out to be? It is already given that u relative is equal to your u. Okay, so vector u, and all these are in vector symbols. When we make them scalar, that is, when we assume one of the direction is positive and one of the direction is negative, plus and minus signs will be introduced based on which direction each vector is facing. Okay, so from rocket equation, let us see. As dm equal to dm is smaller than 0, what does it mean? That is your change in mass. Okay, dm means your change in mass. Your change in mass is smaller than 0. Why? Because the mass of the rocket is reducing, right? So what do you have in the scalar form? You have m dv equal to minus u dm. Why do you have like this? From here you have something of this kind. This dt and this dt can be neglected now, because they are on the both side of the equal to sign. So never say that this dt and this dt actually cancel out. Never say like that. Okay, because this is differential symbol. This is differential. Dt is a differential quantity, it is not a number. So you cannot say that this dt and this dt have been cancelled from both the side. You cannot say like that. Okay, now when you remove the vector sign from here, you remove the vector sign from here, suppose, and you remove the vector sign from here, suppose, then what do? You actually put the negative sign in the front. Why do you put negative sign in the front? Because you know this very well, that your u will be negative. Your u will be negative, and your dm, that is also negative. So negative and negative will be positive, right? So that's why you put a negative sign over here. So when we convert this particular expression into scalar form, you know this very well, that v and u are directed in the opposite direction. V is the velocity of the rocket upwards, in the upward direction, and u is the exhaust velocity of the gases with respect to the rocket in the downward direction. Okay, so they will face in the downward direction, so minus sign must be applied over here. So your m dv will be equal to minus u dm when you remove the vector sign and put everything in the scalar form. So then what is the next step? This m will go over here, this u will come over here, right? The minus sign remains as it is on the right hand side. Now we have to integrate within the limits of, now m is a function of time. It is already asked in the question that how the mass of the rocket varies with time. That is, you have to find out mass as a function of time. So integrating within the limits of m of t, what do you do? Actually, you have your initial mass equal to small m naught. It is already given to you. Initial moment, the mass of the rocket equals small m naught. So when you integrate over here, small m naught will come, and the upper limit, that is the final mass, will be something. Okay, that you have to find out. That will be your, let us assume that the mass changes from m naught to m, then this integration will be integration m naught to m dm by m, and this dv by u, what will you do to it? So your u relative is a constant. Exhaust velocity of the gases with respect to the rocket is a constant, as already given to you in the question. So the takeoff velocity of the rocket just before takeoff is 0. So at time t equal to 0, the velocity, initial velocity of the rocket is 0. When the velocity of the rocket was 0, at that time m naught was the mass of the rocket. And when the rocket has achieved a velocity v, at that time the mass of the rocket is m. So you integrate accordingly, and you get v by u equal to minus ln m by m naught. Okay, v by u equal to minus ln m by m naught. Now this m by m naught is equal to e to the power minus v by u. Okay, now m equal to m naught e to the power minus v by u, but v equal to v naught plus at. So your v naught, that is your 0. Now how did this come? This came from v equal to u plus at formula, right? V equal to u plus at formula, and there is no gravity acting over here, so you can clearly apply this formula, v equal to u plus at. Now your u is equal to v naught, and that is equal to 0, so v equal to will be your at. As the acceleration is constant, already given to you in the question that acceleration is constant. As the acceleration is constant, you can apply the equation of kinematics, that is v equal to u plus at, s is equal to ut plus half at square, v square minus u square equal to 2as. All those things you can apply. Why? Because acceleration is constant, as already given to you in the question. So v equal to at, and m equal to m naught e to the power minus v by u from here. And how did from this step to this state, how did the transition take place from this step to this step? Did you understand? M by m naught will be as it is. ln n by m naught means log to the base e. Then this minus sign you took here, e to the power minus v by u will be equal to m by m naught. That is how you have done it. Now m equal to m naught e to the power minus at by u. Okay, so in the place of v, you will put at, so you will put at over here. Okay, so m equal to m naught e to the power minus at by u. So the mass of the rocket is exponentially decreasing, as you can see over here. Okay, so mass after time infinity, the mass will be 0. But in a reality, this exponential graph you must have learnt at the time of JEE in your mathematics, that this exponential graph never touches this axis. It will only be close to touching the axis, but it will never touch this axis. It will only touch the axis at infinity. At infinity it will touch the axis. But nothing of such kind, nothing of such kind of number such as infinity, such kind of number do not exist. Okay, so it is just a hypothetical concept that at infinity, that is at very high distance, the line will touch the axis. That is just our assumption in order to have the convenience of calculation. So m equal to m naught e to the power minus at by u. So mass of the rocket is decreasing exponentially. You should also make graph in the examination. What happens in the ordinary examination of semester, in your ordinary semester examination you derive up to here and you say that the mass of the rocket is decreasing exponentially, and you never make a graph in your ordinary examination, your semester examination of college. There is no need to make the graph corresponding to such an expression. But in your IS physics optional you have to also make the graph too. Okay, you have to make the graph too. Motion of a particle under a resistive force. Now let us understand this. When resistive force is proportional to velocity of the moving body, then what happens? So let us understand what is motion of a particle under a resistive force. Now what is a resistive force? You must know this, that we have till now ignored the air resistance till now. But you must be knowing that your air resistance also acts in real life situations. But we are taking over here air resistance which has some law. Over here we are taking such kind of air resistance which has some law. Okay, some law, some rule attached to it. Random air resistance will be never given to your question, because random air resistance which exists in the real life, in a real life what happens? In real life the air resistance is not directly proportional or square proportional to velocity. It's not like that. Okay, in real life air resistance acts randomly depending on the direction of wind. Okay, but over here we are taking a idealistic kind of over here we are taking a idealistic kind of air resistance which is either directly proportional to velocity, either directly proportional to velocity square. Okay, so things like that. So motion of a particle under a resistive force, when a resistive force is proportional to velocity of the moving body, then what happens? Let us see. So proportional to velocity means v to the power 1. Resistive force is proportional to velocity to the power 1. Now consider a body of mass m projected horizontally. Now you consider a body of mass m projected horizontally with velocity v0 in a medium which offers a resistive force F, resistive force on the body. So we have considered one of the, although the diagram is not drawn over here, but suppose there is a medium and a body is projected horizontally in that medium with a velocity v0, and the medium offers a resistive force on the body. If v be the velocity of the body at a time t, then the resistive force on it, how will it be given? Suppose v is the velocity of the body at any time t, particular time t, then the resistive force acting on it will be given by F is directly proportional to minus v. Negative sign, why we have given negative sign? Because this F vector, that is the resistive force vector, and this velocity vector, those two will have opposite signs. They will be anti-parallel. So whenever two vectors are anti-parallel and directly proportional, you will put a minus sign so that the 180-degree angle is denoted. Okay, so your resistive force will act in direction opposite of velocity. Suppose if you move in this direction, then air resistance will move in this, will apply in this direction. If you move in this direction, air resistance will apply in this direction, right? Because the air resistance has a tendency to oppose, just like frictional force. Just like frictional force, air resistance too has a tendency to oppose the motion. So F is directly proportional to minus v, negative sign as F vector is anti-parallel to v vector. M dv by dt equal to minus k dash v. Okay, now dv by dt is equal to your acceleration. You know this very well. So mass into acceleration, instead of writing mass into acceleration, I have put m dv by dt. Why I have done like that? Because I have to find out the final expression for velocity. Okay, so in order to find the final expression for velocity, I have put instead of a dv by dt, because acceleration is equal to rate of change of velocity. So mass into acceleration is equal to force, and in the place of acceleration I have put dv by dt, so that I can find out the value of v in terms of t. So equal to minus k dash, where k dash is a constant. whenever you remove the proportionality sign, what happens? Constant takes over that place. Okay, now dv by dt, this m will go in the denominator. तर just a minute friends, just a minute. Okay, just a minute. Sorry for the disturbance. Okay, really sorry for the disturbance which you got in between. So we were discussing that f was your directly proportional to minus v and negative sign was applied as f was anti-parallel to v. Now m dv by dt equal to this k dash is a constant. Whenever you remove the proportionality sign, there is a constant of proportionality associated with it. So in order to show the acceleration in terms of velocity, we have done it to be equal to dv by dt, and because we have to find out v, right? That's why. So m dv, this dt will eventually, this m will go in the right hand side. Then what will happen? K dash divided by m will happen. Now you know this very well, that your m, okay, your m, what is it? M is your initial mass. Okay, initial mass of the body. Over here it's not the rocket, it's the body. So initial mass of the body was m, which is constant, and it will remain constant throughout the motion. Okay, this is not a system of variable mass, this is a system of constant mass. So dv by dt equal to minus k dash by m v. Now k dash by m is again a constant, because k dash is a constant, m is a constant. So k, let us denote it by another constant k. So k dash by m equal to k. Okay, and v remains as it is over here. Then v naught to v, v naught to v, dv by v. Okay, this v will come on the left hand side when will become dv by v. This dt will go to the right hand side and will become dt like this. And initial velocity was v naught, final velocity is v, because the velocity was reduced by the resistive medium, right? Velocity initially was v naught, but the final velocity is v. So v will be less than v naught. Why? Because final velocity was less as compared to the initial velocity due to the resistive force, due to the action of resistive force. So dv by v, and then minus k integration, time initially was 0 and then v velocity is there at a particular time t. So that's why you got this thing. So from here this ln v will be there, then you put the upper limit and lower limit of integration, then you get log a minus log b equal to log a by b. Okay, then minus k, and this integration will be t, 0 to t, upper limit lower limit you will put. So you will get something of this kind. Then you know this very well, that ln something is equal to minus kt. Then ln means log to the base e. What does it mean by ln? Ln means log to the base e. So this e to the power minus kt will become v by v naught. So e to the power minus kt, v equal to v naught, e to the power minus kt. Now when t equal to 0, v equal to v naught. We know this very well, that v equal to v naught when t equal to 0, and when t equal to infinity, v will be tending to infinity, not equal to infinity. It is wrong to say that t equal to infinity, because infinity is not a number, not a defined number. Okay, it is when we put very big values, when we take very huge values, then we say that it is tending to infinity. Okay, but in reality you can take any number as large as you want. Okay, you can take any number as large as you want in reality. So that is the thing. So as you can take any limit as long as you any time as long as you want. Okay, so there will be t will tend to infinity and v will tend to 0. So at time infinity the object will stop. Okay, the object will stop in the resistive medium. So v equal to v naught e to the power minus kt. Now we know this very well that what we have to find out. Let's see in the question. So we are discussing basically motion of particle under a resistive force. So we are deriving the expression for velocity when your resistive force is proportional to velocity. Then what is the expression for velocity in terms of time? We are finding that. So we have got exponential expression for velocity in terms of time when resistive force is directly proportional to velocity in that case. Now v equal to dx by dt. So what will happen? Then you will put, now for velocity is equal to rate of change of displacement, right? So dx by dt will come in this place. Okay, then v naught e to the power minus kt. Then this dt will go in the right hand side, right? So x naught to x means the initial time is 0. At initial time 0, the distance, the displacement is x naught from some origin. Okay, at initial time 0, the distance traveled by the object is some x naught, and at time t equal to t, the distance the displacement of the object, not distance, displacement I should say rather. So at t equal to 0, displacement of the object was x naught, and at t equal to t, the displacement of the object is x. Now you have put the limits. So what will you get now? X minus x naught equal to minus v naught by k e to the power minus kt minus 1 equal to, this is the expression which you will get. These are just mathematical manipulations, you can integrate it. Okay, how will you integrate it? You know the e to the power integration, you know very well what is that. So you basically applied that. If we take x naught equal to 0, then what will happen? Suppose we take x naught equal to 0, that is the initial, the object is starting its motion without traveling any distance. It is starting from t equal to 0, and at that point we have taken the origin. Okay, suppose your object, this is your resistive medium. Okay, this is your resistive medium, and in this resistive medium, suppose your object starts from here, and here itself you take the origin, and this is a resistive medium which is applying a resistive force in this direction, and that resistive force is directly proportional to v vector. Okay, that resistive force is directly proportional to v vector. So your resistive force will be directly proportional to minus v then, right? Now in this particular case, your object will start traveling in this direction, and it will be slowed down in some time. Okay, and at t equal to infinity, the object will virtually come to rest. But according to this expression, if such kind of medium is there, then this following strictly f directly proportional to minus v law, if such kind of expression is there which follows this rule that resistive force is directly proportional to velocity, then in that case the object will never stop virtually. Okay, you can see over here that your v naught will keep on reducing but will never reach 0. It will reach 0 only at infinity after a very long time. Okay, because it is exponential. But in reality, such mediums strictly following, in reality such mediums which strictly follow f is directly proportional to minus v, such mediums are very rare which follow such a rule strictly. Okay, we are taking an idealistic medium which is going to follow this rule, but in reality no such medium is there, because the orientation of the object also depends. In various, suppose over here, in reality what will happen in real life? In real life the resistive force over here will be different, over here will be different, over here will be different. Okay, depending on what kind of the shape of the object is, depending on its shape. Okay, depending on the shape of this tunnel inside which the medium is kept. Okay, so all these things are certainly there in real life, but we are taking an idealistic situation where your resistive force is directly proportional to velocity of the object. So what happens then? If we take x naught equal to 0, then what will happen? This term will turn out to be 0. So as that term turns out to be 0, x equal to v naught by k, 1 minus e to the power minus kt. Okay, because at t equal to 0, your x naught is 0, because you have taken this point to be the t equal to 0 and this point itself to be the origin from which you will measure the displacement. Okay, the coordinate axes have been situated over here, so your origin lies over here from where the object has started its motion, its journey. So t equal to 0 also you have taken at this point when the object was starting from here. X not equal to 0, that is the initial displacement of the object was 0, also you have taken this particular point only. So x equal to v naught by k, 1 minus e to the power minus kt. Okay, then x equal to v naught by k, 1 minus e to the power minus kt. What will happen? 1 minus something. Okay, 1 minus something. So when t will be approaching infinity, e to the power minus infinity will come. Okay, so suppose t is your approaching infinity, then what will happen? At that particular point when t is approaching infinity, this term will be e to the power minus infinity. E to the power minus infinity is 0, so this term will vanish from there and you will get x equal to v naught by k. So at t equal to 0, t equal to infinity, your displacement will come out to be v naught by k. Okay, so the maximum distance which the object travels when force is directly proportional to velocity, resistive force is directly proportional to velocity, in that case the maximum displacement which the object has, so the maximum displacement which the object has is v naught over k. This is the maximum displacement which the object will travel. Okay, depending on its initial velocity. If its initial velocity v naught is higher, it will travel a larger displacement, it will have a larger displacement, but if the initial velocity v naught is lower, it will have a lower displacement. Okay, so the height of this dotted line will reduce if v naught reduces. If v naught reduces, the height of this dotted line will reduce. Okay, if v naught increases, the height of this dotted line will increase, but the nature of curve will remain like this because it is 1 minus exponential, and whenever a constant minus exponential function is there, you know very well that the graph looks something like this. Whenever constant minus exponential function is there, the graph looks something like this. From where did I get this information that the graph of constant minus exponential looks like this? From where did I get this information? I got this information from the fact which I have learnt at the time of JEE. Okay, I have got this information from the fact which I have learned from the time of JEE. So this is the thing. So we have successfully found out the displacement as well as the velocity, okay, of a particle moving under a resistive force. But what kind of resistive force? A kind of resistive force in which resistive force is proportional to the velocity of the moving body. Okay, so motion of the particle is there under a resistive force, but that resistive force is proportional to the velocity of the moving body, and it is not necessary that always the resistive force will be proportional to velocity of the moving body. So in some cases the resistive force might also be proportional to the square of velocity of the moving body. In some cases the resistive force might also be proportional to the cube of the velocity of the moving body. So it depends from situation to situation, but we have successfully derived the expression for velocity at any time t and displacement at any time t for an object. Okay, velocity at any time t and displacement at any time t for an object which is moving under a resistive force with resistive force proportional to v. Okay, So these are the expressions for velocity and displacement. Now I give you a homework. What type of homework? Suppose this is v square over here. Suppose your resistive force is proportional to v square. Then what will happen? What changes will come in the expression? All those things you have to find out yourself. You have to do them yourself. You will also have to draw the graph too. You should draw the graph too along with that. Okay. So we will learn about particle under gravity, but about it we will learn in the next class. Okay. So thank you very much. Jai Hind, Jai Bharat. Keep yourself healthy and calm. Thank you.